Hi everyone,
Hello, welcome back.
welcome back. Got we've got people ready.
Kevin's melting the butter for the popcorn.
Steph is melting the popcorn.
Hopefully, you don't touch your bed after eating popcorn.
Yeah, that would be the antithesis of today's stream.
Yeah.
It's the opposite of getting first layers.
Yeah, first layer on adhesion.
Cool. All right. So yes, today we have um, a stream that's all about how to get very, very good first layers,
Yeah.
because that is probably like the number one thing we hear people complain about online and like just in general. I think anyone who's ever 3D printed knows the struggle of getting a good first layer. And once you get it, it's kind of you're locked in pretty much.
Yeah,
Once you know the basics behind it.
once you can get a good first layer, then you're set. You can get your rest of your print looking good, but you need a good first layer in order to even have a print.
Right.
So it's the most important layer, and that's why we're spending a whole stream talking about it.
Yeah, so this will be a good resource. Even if you get really good first layers, you might learn something new. But yeah, we're planning to go over, everything we've learned printing thousands and thousands of parts on our print farm and actually thousands of different shapes and different parts.
Yeah.
Um, we've
So
tried,
we have some pretty complicated first layers. So some parts that we actually ship out to customers. We're going to tell you how we slice them. Um, we're going to talk about some sort of hidden settings that you might not know are even available to you. Uh, and also we're going to get into some of the physics behind why certain setting changes can actually help improve your first layer. Not just saying do this because it's more like this is the physics behind why
mhm.
these things actually help.
Yeah, once you, I guess for me at least, having that understanding helps apply this type of advice to like any new part I see, or
Mhm.
if I'm trying to print in a different way, knowing how and why these settings do what they do, helps me make adjustments.
Yeah, that's like in a lot of things. If I know why I'm doing a certain thing, it actually helps me actually learn uh, a lot better than just being told to do it because I told you so, and
Yeah,
this is the best thing to do.
yeah, it's like I hope one of our tips is not just level bed, which is like the first thing you'll get anytime you post online. Help, my first layer is not good.
No, in
Everyone just
fact, I
like,
think we assume that we don't tell you to level your bed.
yeah, that's
None
not
of
one
these
of our
tips are
five
level your
tips.
bed.
Yeah,
We've assumed you've graduated past level your bed.
yeah. Also, that's not a fix all, and we'll tell you why. Even with a
Yeah.
perfectly leveled bed, you still need to get these settings right.
And actually, our beds don't need to be perfectly level for stuff to work.
Yeah.
So some of these settings allow you to have some inconsistencies and still get reliable prints.
Um. So yeah. So we tried to boil it down to we have five tips and then like maybe two secret tips.
Yeah, 5 tips because that's what we said in our title. But there's 2 more tips that we kind of just thought of, but
They're
they're
secret.
secret.
They're
Yeah,
secret
yeah,
ones.
we'll get to them later.
Yeah. So maybe guess what some of the things we're gonna talk about are.
Yeah. What is a secret first layer? Actually, in chat, are there any secret first layer settings that you use that maybe other people aren't aware of?
That's a good one. We
Yeah.
could talk about those. Okay, so before we get started, we have a couple of like development updates. So multi-hub, there's going to be another patch coming out soon, um, that addresses some of the things with tags. Tagging is a really, really complicated system, and we got a lot of really good feedback and also a lot of well done bug reports, which has been really helpful. So a lot of those have been fixed now, and we're planning to send out an update. Um, that update might have a couple other new features as well. So yeah, those will
Cool.
be automatically installed on anyone who's part of the multi-hub beta.
Automatic installs. So I'm looking forward to that everywhere.
Yes. The next mainline Quinley update will have automatic updates as well.
So forget about flashing your SD card and
Right.
having to upload files again. That's going away soon.
Yes. Next update. Literally the next update will be
Yeah.
that'll be the last update that you have to do manually.
I saw a pretty cool time lapse this morning.
Yes. And
That's getting pretty close, I think.
yeah, it's in testing now. So it might even be rolled into the multi-hub beta.
Cool. So we're working on the time lapse mode for Quinley, where you get a time lapse of your print, and also you get the like a live, I guess not a live, but like a video of the part getting pushed off, so you can see if there's any issues when parts are getting released, and you can see the whole part being printed.
Mm-hmm.
And it's like a smooth print, smooth time lapse, not one of those really jittery ones where everything's flying around everywhere.
I've actually found it to be really useful for just going back through my job list and seeing if something went wrong, where it went wrong.
Yeah.
It's been quite helpful for that too. Also just looks really cool. And then the other thing is we've opened the betas for Artillery Genius and the Ender 3 Max. So if you have any of those printers and are interested in joining the beta, there's obviously a discount for joining the beta. So definitely get in on those before they close.
Yeah, they're available on the 3DQ shop, shop.3dq.com. You might have to go to the second page of the shop to access them, but they're there. And also, if you're interested in printers that we don't yet support, you can send us an email at support@3dq.com, and we'll put you on the list for printers that we don't yet have kits for, but we'll have kits for if enough people are interested. So,
yeah,
just for
and then we have two kind of, I guess, general product announcements. One is Quinley Vision. We sent out press release this morning, I think.
Yeah, Quinley Vision is in the wild.
It's in the wild, yeah.
Everyone should know about it. There's a couple articles about it already.
Oh, really?
Yeah.
I haven't seen those yet. That's good. That's
Yahoo Finance has an article.
Oh, weird. Okay.
And
thank you.
Yeah, it was pretty cool.
That's cool.
Yeah, a couple other ones, but we'll see them coming in over the next few days.
Yeah. So, and in addition to that, we'll have a bot in our Discord that you'll be able to submit images to, and it'll give you back predictions. So just keep an eye out on that because that's going to be pretty fun to test. You can send any image. There'll be some guidelines that'll, because it's still very early stage, there'll be some things that'll help you like with lighting and stuff. But you actually get to test it for yourself, which is really exciting. And then the next big thing that we're doing in the next couple of weeks is splitting hardware and software. So in our store, you'll be able to buy separate hardware components, and you'll also be able to buy the software separately. And the reason we're doing that is so that we can support a wider range of printers. So if you guys had looked in the Discord, we're adding a custom wipe routine feature, which means that you could plug Quinley into something like a CR30 and actually have it on the same network as your other automated printers. And then we're also developing just a way for you to hook up manual printers as well and still get some of the benefits of like shared queues and stuff like that.
Yeah. Because like the hardware was actually the bottleneck for us. Like like we have to do these betas because we need to make sure that all these parts fit properly, and there's no parts getting stuck in places. But the software works with all these printers that we don't currently have hardware for. So separating hardware from software will kind of allow a whole bunch more printers to be supported.
Mm-hmm. And people can design their own hardware as well.
Yeah, and but looking forward, we want to have some sort of way for, if you've designed your own hardware for, some printer that we don't yet support officially, then you can share that and other people can download those parts and print them.
Yeah, so that's kind of all the really exciting stuff that's coming out. And I see in chat we've got a couple suggestions for first layer tips. So okay, let's see. So Al says 225/65 first layer, then drop to 205/60 for PLA plus. Kevin says Oh, line width and actually Elsa's line width as well. These are both suggestions we'll be talking about and why line width helps. Um,
No fan.
no fan is also a really good one. I think
Yeah.
a lot of people don't realize like how much a fan on the first layer can be hurting them. Again, it can just cause warping too.
Yeah.
Um, okay, shall we get into it?
Let's get into it. Yeah. Yeah. So what's one of the like the first setting that you look at when you 3D print anything?
Shall we go into Kira and check?
Yeah, what's the first setting that shows up? Yeah,
Okay,
let's get into
let's
Kira.
check in Kira.
The first setting
The first setting. Oh,
is layer height.
layer height.
That's a pretty important setting.
Why is that important?
Well, I guess it's the core of 3D printing is printing things in layers.
Hmm.
And then knowing how thin each layer is determines kind of like the quality of your part. So layer height does make a lot of sense to be the first setting in Cura. What's the second setting in Cura?
Oh, well, it's initial layer height.
Initial layer height.
Why is that one important?
Well, it's just as important as your layer height, but it's more important than
It's
your layer
more
height
important.
because your first layer is your most important layer. So um, having a very good first layer is very important. So initial layer height determines how much material you're extruding on your first layer. And I guess by default, a lot of slicers and a lot of profiles don't have, um, they don't make any differentiation between initial layer height and normal layer height. So a lot of people will just use 0.2 as their standard layer height for everything, right? First layer, second layer, the rest of them. What we're saying is you should in fact have a thicker first layer than the rest of your layers. Or in fact, like your first layer should be significantly thicker than 0.2 millimeters, unless you have a very good reason not to be doing that.
Hmm.
Um, so yeah, like why? Why would we benefit from a thicker first layer?
Well, I think the easiest thing to think of is that it allows for a lot more tolerance in your bed level.
Yeah,
And if you're printing like we do, where you have vastly different parts that are being printed all across the bed, one after the other, we don't want to be constantly calibrating the printers. So by having a really thick first layer, you end up with a lot more tolerance um, in that level. So when people
mm-hmm.
say level your bed, um, like if you want to get good quality prints, the reason most people go to that is because when people are printing at very high quality, like zero point 0.1 layer height, Kira will automatically set your first layer to 0.1, and that makes your bed level tolerance really, really, really thin.
Yeah,
Um, Whereas, like for us, or even in my profile, like the one that I personally use, I'll usually print higher quality stuff at 0.2 layer height, but I'll still have the first layer at 0.4 because it means I don't have to worry about my bed being perfectly level
yeah,
every single time. And I know like at home my probe is not super accurate. So, just changing that one setting saves me a whole bunch of calibration and headache.
yeah. And specifically with with a vapor bed, the farther away your nozzle is from your bed, the more happy I feel because you don't want to
Right.
accidentally like dig into the bed. So if your nozzle is like just like 0.2 or even 0.1 on your first layer, then if your probe measurements are just slightly off, or maybe your bed's slightly tilted, um, if anything's off by 0.1 millimeters, then that nozzle is going into the bed, and
Mm-hmm.
not just the vapor on a lot of surfaces that'll cause like a scratch, and if your nozzle's too far and you're trying to print 0.1 millimeter layers, then you're just going to get like a tiny string of spaghetti that doesn't actually stick to the bed. So there's a lot of reasons why having a lot more material coming out of the nozzle is really good for that sort of uh, having a bit of wiggle room, I guess you can say.
It's also generally not that noticeable in your prints because every layer above it is going to be can be at a much higher quality. So
Yeah.
it's not like you're ruining the quality of your prints. Like here, I'll show an example.
Yeah. Like
Um,
devil's advocate, some people will say, "Oh, I don't want my first layer to look worse than the rest of my layers."
right,
And in some cases, that is a valid concern. Like if you're super concerned with quality, I mean, just listen to the next four tips.
right.
But um, in 99% of cases, I don't find that having a thicker first layer makes any significant difference in quality. Um,
Yeah, I'll show you an example here.
yeah, we've got our webcam here showing this is our wireless hub cover, and you can't really see much difference from our first layer um,
You
compared
can
to the
tell
next.
that it's thicker if you look really, really close.
Yeah, and part of that actually comes from, I guess, the slight amount of switch that it has.
Yeah,
Um,
because the bed doesn't have to be perfectly level,
yeah,
but it's almost unnoticeable.
and you could show the bottom surface of this hub case is pretty interesting, actually. It's one of our more complicated first layers. It's got it looks almost like infill. It's not infill. Those lines are modeled in, but we print these on loop without, anyone watching those first layers go down, um, because our settings are pretty consistent and they just don't fail. And even like the sharp tip of that Q, all these like really thin lines, they don't actually peel up. They don't have defects on them, um, because we're putting all of these settings into practice with our slicing.
Yeah, we'll talk about that part more later.
Yeah,
Al brings up a good point too that it means the first layer is a lot stronger. So if you're doing something where you have, not very many bottom surfaces, it can improve the strength.
yeah. Actually, it'd be like yeah, just a solid material. There's no layer adhesion to worry about. Okay, so we covered initial layer height. So the defaults are usually too thin, mainly because most slicers make it a function of your normal layer height.
Yeah, if I click this, I think, or no, well, it's saved. So,
That's saved as a separate profile. Yeah.
I don't want to do this, do
Um, we can reload the 3 map.
I? It's kind of scary. Well, actually, you can see on the right,
Yeah.
it set it the first layer height to 0.2, which is doesn't give you a lot of room.
Yeah, it looks like it's a function of the layer height. So it might just be like 25% more.
I think on higher ones, it's just the same. Yeah, it's the same.
Yeah, so maybe it's something like
I think it
always
just,
0.2.
yeah, I
Is
think
that
so.
is that maybe their metric? Like, I don't think that 0.2 should be the default.
It's
I
too
think it
low,
should be 0.3 or 0.4.
especially with things like enders and even brooches. They can be less level than 0.2 sometimes.
Mm-hmm.
And it's not just that they might be unlevel, it's that the probe might not have probed at the right offset between prints, or if you're on a manual printer, taking the bed off, flexing it, and putting it back is going to make it a different height than it was before. So this tip kind of is universal across printing. If you want to get repeatable prints with good first layers, the easiest thing to do is to set that first layer height um, thicker than you normally would. We recommend what, 0.3 to 0.4?
Yeah,
Yeah.
I'd say that's pretty good. Like, even with a thicker nozzle, if you have a 0.8 nozzle, I'd go up to 0.6.
Mm-hmm.
Um,
That would never, yeah, then you would never have to level your bed,
yeah,
like pretty much.
essentially.
I know I've had a case where on the ender one of the wheels completely came off of.
Oh, the leveling wheels
Yeah,
fell
and
off.
so the bed was really tilted, um, and the probe was still able to compensate to some extent, but I think it was because I was printing with thick first layers that
Mm-hmm.
it actually continued working like that for about a day before I noticed, like, oh,
Right.
there's a wheel in my pile of parts.
Yeah. So it can also save your bed from damage if your printer falls apart while you're not
Right.
watching it.
Yeah, exactly.
Okay, so I guess just to recap, having a thicker first layer means, first of all, you get more wiggle room between your nozzle and your bed, so you don't have to have a perfectly level bed. And it also means that there's more material coming out of your nozzle, meaning that I guess if you have slightly too squished or not squished enough first layer, it'll still print fine and still stick fine to your bed. Um, and I guess additionally, the defaults in most slicers are too thin by a factor of 2 or more. Like
Mm-hmm.
0.2 is too thin. We think you should be aiming for about 0.3 or 0.4 millimeters for your first layer thickness. And you can even go higher than that if you have a bigger nozzle.
Yeah. If you have a like that, and this will just make calibration on your printer and maintaining calibration over time much easier because you have so much more tolerance to work with it.
Oh,
Okay.
Kevin's got a good question here. Are you not using the magic numbers? Yeah, I've actually stopped using magic numbers. The idea behind magic numbers is that you want your layer height to be with increments of 0.04 because that corresponds to a full step on a stepper motor. But I found that it doesn't change print quality. And that's just a subjective thing. I've just noticed that when I set my layer height to anything, it doesn't change print quality. So I've stopped caring about it.
I thought someone found out that on the ender it was 0.05,
0.05.
which is why the round numbers don't matter. But I don't know. I've never used magic numbers myself because I started printing on a delta where there's not really such thing as a magic number because the
Yeah.
coordinate system is so
Oh, that
insane.
makes sense. Yeah.
Yeah. But even on an ender, I've never found that to make too much of a difference for me.
Yeah, I think it's because, well, the stepper motors have 200 steps and your Z-axis lead screw has 8 millimeters per rotation. So I think if you do the division, 200 divided by 8 millimeters,
Yeah.
you get 0.04.
Right.
Or, yeah, I think that's it. Check my math. But I think that's about right. Or 8 millimeters divided by 200 should get you 0.00.
But then you have stuff like micro stepping
And then there's micro stepping, which could
Right.
have fixed all those problems anyway.
yeah.
And when you level your bed, you might end up on a micro step, so then you're going to be micro stepping anyway. So I think it's maybe something you can do if you want to stick within a structure that always use a layer height of 0.04 multiples, but I don't find it makes much difference.
Mm-hmm. CRS1 asks, is flow tailored to the first layer height to give a similar width? So yes, Cura at least automatically will make sure that the right amount of filament is coming out for that layer height. Otherwise, it would just be a Z offset. But yes, if you set it to from 0.2 to 0.4, it'll be putting out twice as much filament.
Yeah.
But we'll also talk about first layer width. That's actually our next tip.
Yeah.
Is talking about first layer width. And now this, there's some more physics behind this one. But yeah, initial layer line width is the next thing that you should look at. We're kind of going from easiest and biggest difference to more obscure settings.
Yeah, or kind of, we're not really going down the list of Cura settings, but we're somewhat following it.
Yeah, it's more like
This one's related to layer height
yeah.
in a bunch of ways. So like, what is line width? And why is line width even a thing? Isn't 0.4 nozzle, won't that create a 0.4 millimeter line? Isn't that how nozzles work? I'm being a bit facetious here.
It can. It can also make lines that are wider and lines that are thinner than 0.4.
Interesting. I didn't know that.
Yes. In fact, yeah, line width is more like line distance. So, yeah, it is.
It is like, if you imagine a layer as like a rectangle, it's got a height and it's got a width. Or, sorry, a line of filament as a rectangle. It's got a height, it's got a width.
Mm-hmm.
And its width is also equal to the distance between the two lines.
So it's kind of like how far apart each first layer line is from one another, and then there's also a flow component to it. So in order for you not to have gaps between each line, it needs to expand the flow a lot more. So do you want to show that on Cura?
Yeah. So I'll set our initial layer, not to 1,000, set it to 100. And this is Cura 5, by the way. So it'll do some funky things with line width. But I actually think that's quite a good thing. But okay, just in general,
This is on a 0.4 nozzle.
yeah, this is on a 0.4 nozzle. So you see here, there's a lot of detail here, and these lines are fairly thin, and that's when it's at 100%. And actually, this is 0.6, so let's just make it 0.4 and reslice. I'm just going to zoom in on like the tip of the Q or something so that we can see the difference here. Yeah, this is nice. So yeah, you can see that there's a lot of little small lines here making up this relatively complicated feature. And I think that there doesn't need to be so many lines to create this complicated feature. You'll see when I increase this. So first layer line width, we recommend, I would say anywhere from 125% to 200%. I've gone anywhere between there. 150 is, I think, where most people will find success. But anywhere from 125 to 200 is a good place to be.
And this is just for the first layer.
Yeah. Yeah, so you can immediately see that there's much fewer lines, and if we're using Cura 5, it's actually made quite a bit more optimal toolpath. A lot less of these like zigzaggy lines, and a lot more of these smooth lines that follow the shape of the part. So I think this will end up looking better when it's printed in real life. And let's even go to 200 just to see what happens. So if you're using Prusa Slicer or Super Slicer, this is probably called something slightly different, but initial layer line width is what it's called in Cura. And yeah, you can see here that it does the same thing with 2 or 3 walls perimeters.
Mm-hmm.
And I'll show you, this is much more reliable than having a ton of little tiny back and forths. If we just go back just to compare.
And the reason for that is that when you have, and we'll talk about this later, when you have a lot of pointy areas or rapid changes in direction, those can induce warping, but they can also just, if you have poor adhesion in general, there's much more chance for it to fail. Basically,
Mm-hmm.
wherever it turns around or wherever it goes quickly around a sharp corner.
Yeah, like if you're, I guess, trying to like print something and you're going this way and then you go back the other way, it'll kind of like peel whatever you just printed off the plate and cause problems.
Mm-hmm. And with thinner lines, they have less surface contact with the bed. So
Mm-hmm.
thinner lines just inherently have less adhesive force. So if you have like an individual thin line and you suddenly try to go right back over it with the nozzle, it's much more likely to peel it back up. Whereas if you have a thick line and then you go back over that thicker line with the nozzle, that thick line is more likely to stay planted because it's got a much higher area of contact. So it's just it ends up improving the reliability of your first layer by quite a lot.
And a fun thing is most slicers keep it at 100% as a default,
Mm-hmm.
and I don't think that's good at all. Like a lot of slicers try to get more first time right results. That means maybe having slower print speeds and making sacrifices to make more successful prints happen more often. But I think a lot of slicers overlook initial layer line width, and they just set it to 100 because why not just set it to 100? But when you set it to something a lot thicker, that'll improve the reliability. And when you're automated printing and you're not going to have someone watching the first layer all the time until you get Quinley vision, but if you're not going to be watching that first layer, then you want it to be as reliable as possible so that there's zero chance, or as minimal chance as possible for anything to peel off the bed.
Yeah. It basically kind of it guarantees that every new line has a higher chance of sticking because every new line that's drawn is being drawn with a larger surface area.
Is this causing us to lag?
It's causing the whole computer to lag.
You guys in chat tell us if the stream is lagging because we're rotating in Kira.
That's crazy. I've never seen Kira do that.
It was fine last stream. I don't know. But okay, so another fun thing about so both layer height and line width, they multiply with each other to increase your volumetric flow rate. So, you know, this line width is the width dimension and your layer height's the height dimension. And when you multiply those two together, you get, I guess, an area. And that's like the cross section of your line that you're drawing. And when you have more material coming out of your nozzle, that means you have more heat energy coming out of your nozzle. And this is kind of speculation, but I think when you have more heat energy coming out of your nozzle, then you have like the material that comes out stays liquid for longer. It takes longer for it to cool down to the bed temperature. And that means that your nozzle, or it's not cooling down right away as soon as it hits the bed. So it's going to hit a 60-degree surface, but the material is like 200 and something. So it's going to take a few seconds for it to cool down to the bed temperature. Whereas if it's really low, like say people who print really thin lines, then that'll cool down to the bed temperature almost immediately. And that might cause it to actually peel up because, you know, the nozzle's still like right next to it. And, you know, the drag forces from material is actually causing like stuff to peel up. But if it stays liquid for like 2 or 3 seconds, then the nozzle and all the drag forces associated with the nozzle, they're all the way over there somewhere. So having more material means that it stays hot for longer so that when it's finally cooled down and solid, the nozzle's very far away and doesn't have an effect on the lines.
I know that there was a thing with like a paper written about not for first layers but for interlayer adhesion where it was saying like a higher thermal mass or thicker layers were generally stronger because you would have or hotter layers because there's more thermal mass there and like because more material is coming out at once and it's cooling down slower whenever you do the line right next to it it's still warm enough that you know you'll get like cross-linking or whatever.
Well, 3D printing is basically welding.
Yeah.
Right, you want to if your layer doesn't kind of partially remelt the layer below it, then it won't actually stick to it. It'll cause all sorts of adhesion problems. So
and if you're able to put like a higher thermal mass out of the nozzle, then there's more chance for it to remelt the things around it.
Yeah.
Or at least cool slower so that I don't know if it's cross-linking or what it is, but the remelting dissipates slower and that causes better adhesion. I think
I would imagine there is something called cross-linking. Like polymers do that.
But I don't know whether remelting causes cross-linking or not. I would assume it does, but you know, I know for resins that's like anyway, that's a whole other thing. That's how you get whatever isotropic prints with resin is because the resins can cross-link between layers. But yeah, I think there was something where like if you have a higher thermal mass coming out of your nozzle, it cools down slower and it's able to at least adhere better to the material around it. And I think something in principle, like when things cool down slower, they also kind of anneal in a more controlled way than if you just flash freeze something. And actually people in chat were mentioning that earlier, like you don't want to have your fan on for the first layer because you're going to have basically cold filament hitting the bed or cooling really quickly, which will cause stress and warping.
Yeah, and as well, if the filament cools down immediately, then the nozzle is going to be right there moving and causing the cool down filament to move with it. And you don't want stuff to move on your first layer. You want it all to stay stuck down.
So that's all to say that with first layer line width, you get a bigger contact area and you also get more thermal mass coming out of the nozzle, and then combine that with a higher layer height, that creates much better conditions for the filament to stick to itself and to the print surface.
Yeah. Also, I'd say that a thicker line width reduces the complexity of your first layer, meaning less lines have to be drawn to get the first layer to complete. So
Yeah.
Reduces the number of points of failure.
So in chat, Kevin's asking, would you suggest 125 or 150 as a default? I think we would probably suggest 125 to 200%.
Yeah. And I think if you want a starting point, I'd suggest 150.
Yeah.
But feel free to go higher. The only reason you should go lower is if you actually require quality. Sometimes if you have a really thin wall on a section of your first layer, it actually won't print unless you set that first layer line width to be smaller. So just make sure that your first layer is actually printing properly when you're doing this. But unless you have a very complicated first layer or a first layer with very thin lines, then you should be able to get away with 150, 175, something like that.
Yeah, as long as you stay within the volumetric flow rate of your nozzle, you can push the line width really high. But the thicker you make that first layer, the less wide you can go. But yeah, like basically everything about it increases the reliability of the filament sticking to the build plate.
Yeah, I think the numbers you have there make sense. So first layer 0.6 height and 0.8 width. I think it's good to at least keep your numbers roughly the same. You don't want a super wide first layer that's super thin. That's just going to look weird. And it's probably not going to print very well either. So I think that makes sense. And then as you go up in your print, you reduce your line width a little bit and you reduce your layer height a little bit. That makes sense.
Yeah. So to recap, why do we print with wider lines?
Wider lines increase the amount of material on your first layer, and that means that there's more thermal energy coming out of your nozzle, and that causes the print to stay, or the material to stay liquid for longer and adhere better to the bed. And I would also say that it reduces the complexity of your first layer, making there fewer points of failure. And also it reduces the sharpness of your corners somewhat. So there's less chance of a 180-degree turn causing peeling on your first layer.
Yeah, every line has got more surface contact, so every line you print will stick a bit better than with a thinner line width.
Yeah.
Cool. Okay, let's move on to number three. Number three. Print speed.
This is a fun one.
Why is it so fun?
It's because, okay, it's like people who first get into printing, they crank this way up when they really should be cranking it all the way down.
Right.
At least I did. And so first layer print speed, it's the speed that your nozzle moves on your first layer. And
that's a good explanation.
Took a long time to think of that one.
Yeah.
But when I first started printing, you always watch the first layer when you print stuff, and I am impatient, so I just wanted that first layer to get over and done with quickly, so I could know that it was good, so I could go and do other things.
Mm-hmm.
But I would actually watch the first layer, the whole first layer, and what it turns out is that my first layer would fail so often because it was so fast. And so I thought, okay, you just always have to watch your first layer just in case it fails, because first layers have like a 90% chance of failing. What I didn't know is that if I just slowed my first layer down to 10 millimeters per second, then it would fail very rarely, and maybe so rarely that I don't even need to watch it in the first place.
Right.
So I was kind of causing my own impatience. And so one thing I think we should all learn is the zen of 3D printing,
Okay.
which is just learning the patience of having a slow first layer.
Mm-hmm.
And you know, we're not talking about like borons and speed benchies here. We're talking reliable, consistent results from normal 3D printers like Ender 3Ds, Prusa's, Sidewinders. Spending a lot more time on your first layer means that you can get away with having a faster rest of your print. So it actually sets up, it's your foundation, right? It sets up your whole print to be a reliable print. If your first layer is bad, then you're going to get warping or you're going to get a detach. Things that Quinley Vision can detect, but why not just have a good print?
Yeah.
Right?
Yeah, and like that's a good point. Quinley Vision can do that watching of the first layer for you now.
Mm-hmm.
So it means like if you even if you slow it way down and your first layer takes like 20 minutes or 30 minutes, um, you won't have to sit by to watch it that often. It's not going to fail as much as if you print it at 60 millimeters per second. Um, but you know, you wouldn't even have to watch it if you were using Quinley Vision, the first layer, poor first layer detection. So you're not now you can safely extend the time of that first layer and also not have to worry about sitting there for 20 or 30 minutes at a time. Um, and yeah, when you see stuff like speed benchies where they do the first layer at 100 millimeters per second, you have to remember like that part was tuned over dozens and dozens of prints, um, where somebody was starting them, watching them, making adjustments, and you're only seeing the last result in that line of prints.
Yeah, that's a good point.
Yeah, and you don't know how repeatable it is either. Like if somebody had to print 100 speed benchies in a row, would they all be successful? I don't know.
Yeah, it's hard to know because you only see the final results on
Yeah,
YouTube.
you only see the best one. So slowing down that first layer is important. And then, you know, if you don't want to observe it yourself, you can use uh, something like Quinley Vision to watch that slower first layer for you. But just in general, it's going to improve your chance of success um, to print slower. It also comes back to that thermal mass thing we were talking about previously, where if you're printing too fast for your hot end, it's not going to heat the filament coming out quick enough. And so the filament hitting your bed is actually going to be colder than what you set your temperature to. So when people print, are maybe they print like at 30 millimeters per second, they get a good first layer, but then they want to increase it to improve their print time. You also have to remember to increase your nozzle temperature because as soon as you increase the speed, then the filament coming out of your nozzle is going to start getting colder. The more filament that goes through your hot end, um, the more heating your hot end needs to provide.
Here, let's I want to show sort of what the defaults are in Cura, and maybe give some reason why. But also, let's just do some experiments to see what the effect of first layer speed actually has on your total print time. Like, is it really that important? Okay, so
These are default Cura settings.
these are default Cura settings.
Okay.
Yeah, low quality. Let's make it standard quality. Discard changes. So this should be the default profile. It looks very default to me.
Yeah.
So Cura's initial layer speed is not too bad. It's at 20 millimeters per second. In that case, 20 millimeters is actually not too bad, gotta say. I recommend 10. I'm very like reliability focused when it comes to first layers, and some people will say 20 is just as good as 10. I'd say why take the risk?
Yeah.
But okay, why is initial layer speed 20? It's some preset in Cura. They just say set the first layer to 20, and I kind of agree it's pretty low. But let's try setting it to, let's just see how long this part takes to print, and then see what it is when we drop it down to 10 millimeters per second, right? So 3 hours and 45 minutes. So this is actually twice as long as this part actually takes to print, but on our print farm. Let's try setting it to 10. So what was it? 3 hours 45.
Mm-hmm.
What are we saving here? 3 hours 55. So 10 minutes on 3 hour 45 part. It's not huge. It's maybe what, like a 5% difference.
Mm-hmm.
I'd say I would much rather have a print that is reliable and takes 5% longer than a print that is maybe unreliable and uh, takes 5% less time to print.
One of the cool things that you'll be able to do with Quinley Vision is actually track this sort of thing. So if you had the same model and you sliced one with a 10 millimeter per second first layer and one with a 20 millimeter per second first layer, you could tag those separately so that and like track the basically track the yield rates of those. So does this model have a certain amount of, like, how often am I seeing 4 first layer in model A versus 4 first layer in model B? And so you'd actually be able to do that, like see that calculation, is that 5% increase in time, um, which in this case would be like one extra part every 3 days. Is that worth the like 10% increase in first layer fails? Um, I would say no,
Mm-hmm.
but a lot of that level of detail is really hard to track manually. So um, that's the kind of thing, or those are the kinds of insights we want to build out with Quinley Vision, where you could actually run these experiments and see, like, am I sacrificing um, yield rate just by getting this print faster, and where is that balance? Where should that balance be? And one of the things that we have kind of as a longer term goal with Quinley Vision is to even make automatic adjustments to print files uh, over time, where like you could have maybe a variable where it says, if this print is over 95% successful, try increasing the speeds and see what happens. And if it starts, the yield rate starts dipping, uh, don't increase them any further.
Yeah, or you can even look at just the first layer speed and have uh, some sort of, I guess, preprocessor that looks at your first layer speed and says, hey, if it's over 30 millimeters per second, then drop it down to 30, like cap it at 30. Because maybe you're running a print farm at a school and all kinds of kids are slicing stuff and most of them aren't very good at slicing. If you can kind of cap things within reasonable limits, if it's through Quinley or from a slicer, but since you're actually printing through Quinley, Quinley Vision can cap your like first layer speed, for example, just to make sure that you're getting reliable prints, even if you don't particularly know how to slice apart properly.
Because remember that the application is not just machine vision; it's also will take into context, what is the printer doing, what are the temperatures on the printer, and even look at parts of the G-code file to see, to try and correlate them with what it sees is going on. If it detects a poor first layer, or if it detects under extrusion on the first layer, and it sees in your G-code that you're printing your first layer at like 60 millimeters per second, then it's the correction wizard is going to know to say your first layer speed might be too fast, versus something like where your nozzle might be too high off the bed.
Yeah.
Because a nozzle that's too high would cause the same symptoms, but if you look at the G code and you see a higher than average first layer speed, then okay, it's probably that.
Yeah, like things that just stand out based on the G code. Like there's actually some things you can just tell by the G code. And since Quinley Vision will have access to G code files, then yeah, there's a lot of stuff we can do with that information. meaning that we might not even need a webcam to predict certain issues. You know, if you say your
That'd
first
be
layer is
cool.
going to go blazing fast, we can just say this is probably going to fail. Don't even print it.
Yeah.
Change your settings before even pressing print.
Or say like, well, even with Quinley Pro, that'd be possible. Like just the G code level stuff, because you would just say, you know, most of your prints on your farm do not use a speed this high.
Hmm.
Be careful. Like,
Yeah, watch out.
yeah, you're canceling this part like 10 times more often than any other part. You might want to look at these parameters that are higher than usual.
Yeah, automatic, I guess, outlier detection in terms of settings.
Yeah, it's like the correction wizard is just it just to say that it looks at more than just what's coming through the webcam feed. It takes everything into context, just like you would. Like if you were watching your printer, um, and you saw something going wrong, you would look at your slicing settings. You would look at the machine, like what the machine itself was doing, and then obviously you would also be looking at what was wrong with the part.
Yeah.
So it's important to keep that in mind. Yeah, there's some pretty fancy stuff you can do um, when you take all of that into account. And I think that will save people so much time because, like, oh, why am I getting extrusion? And instead of having to go through a troubleshooting checklist,
Hmm.
a lot of that checklist is going to be filled out for you automatically based on what Quinley Vision sees.
Yeah, or it's going to guide you to like these three things are the things you should look at in your slicer.
Yeah.
Whereas, yeah, you'd have to read a whole guide just to know where even to start.
Hmm. Okay, so to recap, first layer speed, what does that help us with?
It makes your material coming out of your nozzle closer to the temperature of the nozzle, first of all, so that you're not getting material that's too cold. When we're printing too cold, you're getting bad adhesion to the bed. And with vapor bed, with other beds, having bad adhesion to the bed is probably the first cause of bad first layer problems. Could have said that better. But yeah, when material comes out of the nozzle and the material is too cold, it doesn't stick to the bed. So when you're printing really slowly, that makes sure that that material actually reaches the nozzle's temperature. And especially when you're printing really thick lines, then you might actually get close to your volumetric flow rate if you're printing at normal speed. So you have to print slower than that just so that you can pump out a lot of material per second and a lot of heat per second so that stuff sticks to the bed really well. I would also say that printing slowly reduces the risk of any sort of, you can't have a hard direction change, harsh change in direction, because you're only accelerating from 10 millimeters per second this way to 10 millimeters per second that way. Whereas if you're going blazing fast, then you might have a really fast change in direction causing something to peel up. So if you cap your speed at something really slow, like 10 millimeters per second, then that reduces any sort of peeling that could happen on your first layer.
One of the other things, you can compensate for a slower first layer by doing a wider first layer. So if you drop from 30 millimeters per second to 15 millimeters per second, but then double your line width, you still have the same amount of material coming out, and your first layer will take the same amount of time.
That's true. Yeah, that's a good point actually.
Yeah,
And
that's
in fact, if you do it properly, you can keep a consistent flow rate throughout your entire print.
yeah,
And if you know how fast your nozzle can, whole hot end and extrusion system can print, then you can just say, hey, make all the variables in your first layer multiply such that it also hits that maximum flow rate.
hmm yeah. Even if it's moving slow, you can still be putting out a lot of material at once.
Yeah, it's actually just a multiplication of line width, layer height, and print speed.
Yeah, I'd be
That's your
curious
flow rate.
to know what people watching what first layer speed they do, because I know a lot of people watching right now um, are using automation, so they have had time to optimize better, and I wonder how much they've pushed the speed up from 10 millimeters per second. I
Mhm.
think we use 10 millimeters per second just because it's like so reliable and we print so many different parts. But if you're only printing a couple parts, it makes more sense to try and increase that.
Yeah.
Also, we just do really, really thick first layer like lines.
For things like the Wong box, I think we actually use slightly faster because that first layer does take a long time. It's it's a huge square essentially, and if we printed it really, really slow at 10 millimeters per second, it would actually take an hour to do the first layer. So here's actually a really good part, a great example of first layer uh, speed being a really important factor, and I guess line width as well. But you can see these really sharp direction changes on the top part of this ramp, and any normal print settings, like the default Cura settings, I doubt that it would actually be able to properly print this thing because it's trying to print this maybe at a slightly faster speed, but also with really thin extrusion lines, and there might not be enough heat energy to keep the materials liquid for long enough. I think it'll actually peel up when it does that direction change. So this is kind of the surface quality of the parts that we get from automatic printing. Like this printed at some point overnight last night, and no one was there to watch the first layer.
But we
So
print dozens and dozens of these one after the other without any issue. And like
this
this
is
is
one of 10 that printed.
okay. Overnight, right?
Yeah, among other parts, but 10 of that part.
Yeah, and this, I think most people would consider this to be an extremely risky first layer, but this applies the layer height, line width, and slow speed that we've talked about.
Yeah.
Like you can actually see here how crazy the line width is.
This actually did take a while to get it right. For fun little fact is we also have to print outside walls first on this part because you might be able to see that there's little dots of filament everywhere once in a while. And if you print those first, then they'll just fall right off the bed. So you have to set it to do outer walls first and then print the rest in beige mode. So
Yeah.
this is the fun part. I really like talking about our vase mode prints because they just look so good, and
They're kind of crazy.
I think they're optimal. There's no way to increase the there's no way to get better than that.
Yeah. It's
We
like
don't even need to cool the bed down, by the way. You know how people say, oh, vapor bed, you have to cool it down to 29 degrees. I bump these parts off at 55.
That's bad advice though. That can cause damage to the bed.
No, but this part is so thin. There's very little
Oh, I see.
contact on the first layer, so they just leverage them right off.
That's I would not recommend doing that long term.
For anything bigger for the first layer, it's down to 30. But
Yeah, that's like
these
that's
guys just
pushing
fall
it.
off right away.
Yeah. Still, I don't know if I would do it at 55, maybe at 45.
All of them printed fine. Oh,
Okay.
45 actually would be fine
There's
still,
gonna like if we print 100 of these, there's gonna be like a hole
but
shaped like that first layer, maybe.
yeah, I guess there's very little adhesion when they actually pop off.
Yeah,
But yeah, if they were
that's
bigger, I wouldn't do it. But I know the vapors like to be pushed off at a bit of a lower temperature, but
Slade says he does default 50 millimeters per second. One thing we were saying was you can drop down that first layer speed and then just compensate with line width. Um, but it also depends on what you're printing on. Like if you're printing on something like the Ender default bed, like a polycarbonate
mhm.
bed, um, then you can go really fast because it's like literally the plastic is just being glued into the surface. But then with those beds, you do have to scrape them, which is a whole other thing.
Yeah.
Yeah. So you kind of pay for it with doing that. And that's not to say you can't get up to 50 millimeters per second at all. It's just like whether when you're trying a new part and you just want to put it right into production, you should start with a slower speed. And if your production is successful, like your production rates are really good, then start bumping up the speeds. We actually did a whole stream about like pushing speeds on production where we've taken 3-hour parts and brought them down to 45 minutes.
Very similar to the ones we just showed, actually.
Yeah, very similar to this part. I mean, this part is
It's basically the same, but for the Prusa.
yeah.
Um,
Anyway,
yeah.
depends.
So
Yeah, I
50 millimeters per second, you can certainly do it. It's just that, maybe 1 in 10 times you'll get a bad first layer and your part will fail. Or you just have to watch first layer.
Mhm. Yeah, it also depends on what scale of parts you're talking about, because dealing with 1 out of 10 bad parts is okay, but then if you're printing 1,000 parts, like dealing with 100 bad parts is really difficult.
And it also means you have to know your printer too.
Yeah.
Because we have many printers in our print farm, so we have to slice G code that'll work on every printer.
Hmm.
And we don't know intimately all the details of each printer. So maybe we want to make sure it's reliable no matter what printer it's printed on. We get a question from Discord or something?
Yeah. So, well, it's a fix my print post. I'm just trying to figure out how to show it.
Oh, okay. We could go to fix my print. Is it like a common, or is it a recent?
Yeah, it's
Post?
from 6 hours ago.
Is this from Steph?
Yeah, I have no way of displaying just the image though. Let's see.
Well, what is it? We have a guy with weird bumps on his first layer. Looks like his first layer is too close, I would say.
Yeah, let me pull up the image on the screen.
I mean, that's a common thing is people squishing their first layer so much because they can't get good adhesion any other way. And when the actual solution is by actually looking at the previous 4 steps that we just talked about, initial layer height, initial layer line width, initial layer speed, and modifying those to be more reliable. But a lot of people just get by squishing their first layer super hard, but then they get elephant's foot, they get a really rough surface, and the bottom of their prints will look really bad. Usually there's this weird, where lines overlap incorrectly and they have this weird mottled or fish scale effect.
Here it is.
So yeah, this is kind of what happens when you print too close to the bed.
Yeah. This is all that's why he's getting that stringing as well. Because it's
It's
just
over extruding essentially.
excess flow or excess pressure in the nozzle.
Yeah.
And yeah, the plastic is trying to escape however it can. So you end up with like, well, trying to escape however it can, and it's also pushing other material that's already there out of the way.
Yeah, like it's kind of spilling over, I guess, on either side of the line, and then the strings
Yeah.
whenever it travels.
So this would be interesting, like to try with Quinley Vision, because I think it would probably detect the over extrusion.
I've seen it. We have some examples of it detecting over extrusion on
Yeah, it would definitely
parts similar to this, like
pick up
black PLA.
the stringing. It would pick up.
Yeah.
And then with the context of if you're getting stringing in your first layer, we might be able to make it so that it knows like, oh, well, it's probably over extrusion.
Yeah. Yeah, so that was one thing with the print correction wizard is we're planning for it to look at combinations of fails and being able to fine tune its suggestions if you have a certain combination of fails that fit a very particular problem. So maybe bad first layer, over extrusion and stringing means that your nozzle's too close. And that could be supported by data, or it could just be based on like expert knowledge.
Yeah.
Probably maybe a combination of the two.
Yeah.
Nozzle too close
Yeah,
for
Al's
sure.
got it right. Okay, let's move on to the next tip again that we've kind of running our farm. Okay, this is probably one of the biggest ones that I see people get wrong often, and
Yeah, this is definitely the most common one.
it's not like it's not even like it's not through their own fault or anything. It's just that the information that's out there is generally for very specific circumstance.
Yeah, and actually, I think there's a lot of misinformation as well,
Yeah,
um, on certain communities. But
can be.
yeah, I see a lot where people will say, "Oh, your first layer is overheated. Cool it down." That's not a thing.
Right.
Overheating the first layer, it's
So yeah,
something else.
we'll talk about so there's
If you,
temperature is a huge component in uh print adhesion,
mhm.
and we'll talk about bed temperature and nozzle temperature separately. I think when people are think about how do I get a part to stick to my bed, the first thing that their mind goes to is um, bed temperature, like beyond adhesives. They think about bed temperature.
Mhm.
Um, but what a lot of people don't realize is actually nozzle temperature also plays a massive role in getting good adhesion. Because if you're extruding cold filament onto a bed, it's not going to stick. The filament has to be soft, or it has to be um, liquid when it's deposited. Otherwise, the adhesion is just going to be really bad. And generally, the more like liquid it is, the better. Obviously, you don't want to go to the point where the filament is turned into
Burning.
burning, yeah, or like decomposing in the nozzle.
Yeah,
Um,
you can get, it's called hydrolysis actually. For
really?
this. It's called hydrolysis. Yeah, new word. Um,
What does it mean?
so I guess
Is it like when the
it's
water comes out of the plastic?
honestly, I want to claim that I know what it means,
Okay.
but it's something to do with like bonds breaking and chains dissolving. But I don't actually know the answer. I just know that it's called hydrolysis, and it's whenever you get that really sticky goo that comes out instead of actual
Oh, okay.
filament.
Yeah, like
And
when,
if you print really hot and really slow on your first layer, you can sometimes get some weird, disgusting material that's not really PLA anymore.
hmm it's like syrup.
Yeah.
Yeah, I
And it
know
doesn't
it's
ever cool
almost
down to be rigid. It stays slightly sticky. So,
yeah, it's like the plastic is decomposed into something. I don't know. The
yeah.
resin is gone. It's something else. Um,
So defaults though on first layer temperature, I see a lot of people stick to 200 as
for PLA.
PLA is 200. That's just what you print PLA at. So 200 degrees. And a lot of slicers, I think, also do this.
hmm
I've seen anywhere from like 200 to 210 as like a default for PLA, when I strongly believe it should be anywhere from 230 to 240 as your uh, first layer temperature. And there's going to be like people right now being like, oh my God, 230, are you insane?
Yeah.
But no, no, this is actually what we do for all of our parts now. And it's been the most reliable, like, it's probably been the biggest change in reliability. Um, it's just increasing the first layer nozzle temperature. Um, One of the things that it does is, as Mateo said before, it makes it more liquid. So as thermoplastics get hotter, the viscosity decreases. It makes it more easy for it to come out of the nozzle.
hmm And the way a lot of print surfaces work is by having the plastic interface with like a matte finish, or on the Creality beds, it's a rough ceramic surface, or on the plastic Creality beds, it's interfacing with a rough polycarbonate surface. So in order for material to grip onto those beds, you want them to be, or to conform to those beds.
Mm-hmm.
Hotter is usually better.
Yeah,
Um,
because if it's cold, then it maybe doesn't even have time to settle into the finer surface crevices on the bed.
mhm.
And even on smoother surfaces, I think this still has some effect. There's still atoms, and the bed's not going to be perfectly smooth. So there's always going to be some benefit to having a hotter nozzle temperature than usual, no matter what bed surface you have.
Kevin brings up a good question. Do you think those suggestions have to do with many of the hot ends being PTFE line? It's possible, although, the if a hot end is designed correctly, like actually printing PLA at 240, the PTFE should never get up to 240 itself. Um, because you should have material moving through it constantly, and that keeps the heat from creeping up. And of course, you also have um, the hot end fan as well. So
Yeah, so like I think Creality hot ends, they do have PTFE touching the nozzle,
mhm,
so you wouldn't want to actually print hotter than 245, I would say,
yeah,
on those. But on our farm, we we do first layers anywhere from 230 to 250 with PLA
on all metal hot ends.
using all metal hot ends, and we actually print some of these parts were printed at 260 degrees. This one actually I think was 260 degrees, and it looks beautiful. Uh, yeah,
I
if you,
gotta turn off the green screen.
oh,
Or we'll
okay,
just show it on the
yeah, this guy.
here.
Let's see if I can
I'll
get.
focus it.
Yeah, so this is 260 degrees phase mode, so it does look very nice, but having this good of a surface quality with 260 degrees and PLA, it's not something you would expect to see.
Mm-hmm.
And look at these, these are overhangs, by the way. The part prints, oh my God, the part prints like this. So these are all overhangs, and those are looking very good, I have to say. So all that to say, nozzle temperature is a lot less important, maybe no, a lot more important than you think, and going above the recommended doesn't actually make that much of a difference as long as you're printing fast enough. So the only reason we can get away with printing at 260 is because we're printing really fast. We're printing high volumetric flow rate, lots of material is coming out of the nozzle, and the material is never actually reaching 260. So it's like the opposite of why you slow down your first layer. You slow down your first layer so that the material actually gets to the nozzle temperature.
Mm-hmm.
But if you want to print really, really fast, optimize your print times and all that, then you can crank your nozzle temperature up and crank your flow rates and everything up so that, not your flow rate, make your volumetric flow rate higher using good settings to change it. All that so that your material heats up to a higher temperature by the time it's actually out of the nozzle.
Yeah, it's basically a balance of, how much heat can your hot end provide for the amount of material you're pushing through it. So you definitely, I mean, the reason we print PLA at 240 or 260 even is just because that part that Steven was showing, it has, what is the layer height on that?
0.5.
Yeah, 0.5 layers, and then the line width,
1.0, I think.
yeah, the line width is a millimeter. So it's, that's when you look at the side of a spool and it says print between, 190 and 210, it's assuming you're using a 0.4 nozzle doing standard speeds at standard layer heights. Now for the first layer, it also assumes you're doing 0.4 line width worth of extrusion at normal speeds. But what we're saying is, you can increase the reliability by doing higher flow rates, by doing wider lines and taller first layers. But in order to do those, you should also be increasing the nozzle temperature. And what we recommend, like a lot of people when they first start using the vapor, they're like, hey, nothing's sticking. Like it's almost a foolproof piece of advice. Like an email that I send back is, bump your temperatures by 15 degrees. And then they're like, wow, okay, it sticks perfectly. And it's just nozzle temperature, not even the bed temperature. Because yeah, it just helps so much with adhesion. But yeah, you don't want to go too high, otherwise the plastic starts breaking down. And actually, Al was explaining hydrolysis. He said the crystallization point is the result of hydrolysis. It starts happening right before that temperature, and it's when the filament starts to break down due to a reaction with humidity.
Right. Yeah. So it's like when the chains break. I guess there's some sort of reaction that happens with water and polymer chains. I knew this stuff a while ago and I've forgotten it since.
In university.
No, just throughout my own research. It's looking at what hydrolysis is. There's a guy on YouTube designing his own hot end, and it's for mixing six materials. His name's
Hmm.
Decking Man. He's a cool guy. He's not very popular on YouTube yet, but he's designing his own hot end for six materials. I'd suggest checking him out. But he actually prints at 180 degrees because his hot end is like this long,
Yeah.
and his material actually gets to 180 by the time it's out the nozzle.
Hmm.
And that's very different from what I'm used to, but his reasoning makes sense because he has a huge heating zone, and our heating zone is a nozzle length, which is
Actually, most
small.
most like modern hot ends try to have an extremely short heating zone, or at least a really short heat break, so that you can get good retraction. So you
Yeah,
don't want a lot of molten material in your nozzle, otherwise you're going to have um, stringing and retraction issues. But as a result of that, the filament does not have a lot of time to heat up. So if you're trying to get a hotter first layer or a wider first layer, you really need to crank up the temperature to get that filament up to temperature as it's coming out the nozzle. So for the settings we were talking about earlier with the line width, I think we would probably recommend a minimum of 225 for PLA. Um,
yeah. And
yeah.
that's if you're going at really slow speeds, and maybe your first layer line width isn't super huge and your first layer height isn't super huge.
Mhm.
225 is kind of a minimum, really. I would say if you're trying to get it first time right, 230, 235, you can't really go wrong. I don't think any PLA on the market will actually degrade at 230. Maybe if you leave it in the hot end for an hour. But,
Yeah, if you leave it, that's the thing. If you leave it in the hot end, it might.
mhm.
Um,
But that's only like I think only some PLAs will even do that. I've
yeah,
left my hot end hot for a long time, and you might get some hydrolysis going on. But
you can actually smell it when it's happening.
mm,
It's like that really sweet smell that PLA gives off is when it's breaking down. Um, so you know you're printing too hot if you start smelling that kind of thing. Um, but the other thing that you can do is if you're more interested in printing really fast, I would also recommend turning up the hot end.
yeah, yeah. So we routinely print. We don't print anything below two. Oh no, that's a lie. We print most of our parts at about 230, 240. Parts like this with a lot of detail and
I'm gonna switch to Kira so they see
oh
it.
yeah, true. What are we at? Kira. Parts like this with a lot of detail, we actually print this at 215 because we're using zero point 0.4 lines and zero point 0.2 layer height. So this is normal printing temperatures now.
Hmm.
But yeah, with the other parts that we print with much thicker lines, then we go all the way up to 240, 260. It works fine. So actually, as you can see, the default for Cura was actually 200 degrees initial layer printing temperature, which I think is wrong. It should be 220 at the minimum, even at the most conservative.
Yeah, even for like especially for stuff like glass too.
Yeah.
Um,
Actually, I'm curious if the guy who prints at 50 millimeters per second on his first layer, what is your temperature?
yeah,
I
what
think you're
their
still here.
temperature and line width would be interesting to know.
Yeah. And actually, anyone else in chat?
I mean, when I started printing, I had a glass print surface and I would print on it at um 185, I think, PLA
Oh, yeah.
and 60.
For your first layer or
Yeah,
for the whole print?
for first layer.
Oh, wow.
But it wasn't good. Like I was getting warping on larger parts. I remember that being a big problem when I started. Uh, I would get warping because the adhesion was just so bad.
Right.
Or I would have to use the blue tape or glue.
Yeah.
Um, and like, yeah, those types of things are to compensate for bad adhesion. So, um, yeah, you can greatly improve your adhesion by printing hotter.
Okay. So let's recap. Hot nozzle means the plastic that you're printing is hotter. So that makes it more liquid. That means it bonds better to the surface of the bed because it can actually get into those little nooks and crannies of the bed surface before it cools down to whatever temperature the bed is. Also, it allows you to have a higher first layer flow rate. So the previous 2 or 3 tips were all about having thicker lines and having a hotter first layer. Nozzle temperature allows you to print those thicker lines without any sort of under extrusion. So we recommend about 225 to 235, maybe even 240 for PLA. If you're using the settings that we've all like previously said, 230 is probably a good place to start for a first layer temperature.
Mm-hmm. One other thing is make sure, like, just because you're printing your first layer really hot doesn't mean you need to print the rest of the layers really hot. So you can, there's a setting for the initial layer temperature and the initial printing temperature. You can set those to 230, but if you get the best surface finish at a lower temperature, you can always drop the second layer and beyond.
Yeah.
Yeah, that we do that sometimes too.
Yeah, I do that often with, actually at home when I print parts, and I don't really care how long they take, I just want them to look good. I'll print the first layer super hot, and then I'll drop the nozzle temperature all the way down to maybe 210 or 205, something like that.
Yeah.
And that's for 0.4 nozzle, 0.15 layer height, like really high quality. Which is kind of weird. I don't usually print stuff like that, but I've started that now.
Yeah. Yeah, I mean, it's those, then it makes sense to go within the manufacturer's recommended temperatures.
Yeah.
Like for the rest of the print. But yeah, 230 has been very consistently good for me on paper.
And your first layer is a special layer, so it makes sense for the settings to also be special.
Yeah, exactly. That's why there are separate settings for every, like, there's almost a duplicate of every single setting just for the first layer.
Yeah.
It's just a shame that a lot of slicers don't, they usually just make it the same as the rest of the layers.
Mm-hmm.
I think it's important to know that it can be different and it should be different.
Cool. So I think that was our 4th tip.
Yeah, okay, so our last one.
Our final tip. It's also a temperature related tip.
Well, what other temperature can you set on your printer?
Chamber temperature.
On most printers.
Bed temperature.
Bed temperature. Yeah, so this one's pretty easy. You just want your bed temperature to be close to the glass transition temperature of the material you're printing. So with PLA, that's 50 to 60 degrees. But the catch is that depending on what bed material you're printing on, you might have to have slightly different, I guess, offsets for what you set in your slicer. And what I mean by that is if you have something like a glass bed, the top of the glass bed is not going to be as hot as the bottom, especially when you start your print, because it takes time for the heat to spread through, such as like, because most glass beds are 5 millimeters thick, so that's a lot of material that needs to be heated up.
So also the temperature sensor is on the bottom of the bed, not the top.
Exactly. So you're not getting a correct reading, and a really good way that I would recommend for things like glass beds is to set the initial layer build plate temperature a little bit higher, because if you're aiming for a 60-degree bed, you might want to set it to something like 65, because by the time the thermistor on the bottom of your bed hits 65, the top of the glass should be around 60.
Mm-hmm. And there could even be like steady state error. So even if you let your bed sit for 10 minutes, the bottom can still be 65 and the top can still be 60.
Mm-hmm.
Like that can still happen. It's called thermal resistance.
Yeah.
So glass is a very good insulator, and it's hard for heat to go through it. So
yeah, once it's heated up, it'll stay at temperature pretty easily. But some people print on, like, well, steel sheets are a good example.
Yeah.
The steel sheet on the Prusa, for example, most of the temperature is going to be lost through the steel sheet, so you might have to well, I've noticed like we have to print slightly hotter with the with the beds on our Prusa versus on our Ender where we have a vapor applied directly to the heater.
Yeah, and
Um,
that's onto aluminum, which is really pretty good at conducting heat,
yeah,
not glass, which is pretty bad.
yeah. So we've noticed like even between printers, you might want to look at how the heated bed is constructed. The Ultimaker, for example, it has a um, aluminum heater that heats a glass plate, and that heater, the way it's designed, it doesn't make very good contact with the glass plate because it's actually really flexible.
Hmm.
And what happens is it takes the top of the glass bed much longer to get to the right temperature than if you're doing a glass bed on something like an Ender 3.
Yeah,
I've noticed the contact is actually not super good.
yeah. It seems like the corners get better contact than the center at some point.
Yeah, yeah.
And also, sometimes people do like a magnetic bed surface where on an Ender 3, for example, you have your aluminum plate, and then you got a layer of glue or some sort of heat adhesive, right? And then you have your magnetic plate um, on there, and then you have your steel sheet that connects to the magnetic plate, maybe another layer of adhesive, and then your actual printing surface. And then there's all these different layers between your surface of your print bed and your heater, and that's going to cause a decent temperature offset. Maybe even you need to go to 70 degrees
Hmm.
on your first layer.
Yeah, so you have to consider the thermal conditions of your bed. I guess a rule of thumb is if you're doing if you're using something like a spring steel sheet, you might want to go a bit hotter because it will be. It also depends. Actually, it also depends on the efficiency of your heater too, like and the power that your heater can provide.
Mm-hmm.
Because, um, like on the same printer, a spring steel sheet is probably going to be losing a lot more heat than something like a glass bed. But then between two printers, like different models of printer, the heaters might be different. So you have to consider that for everything. Yeah, like pretty much every printer you use or every type of bed that you use. And I mean, most beds compensate for it by just being like extra sticky and then you have to scrape your parts off.
Or you just put glue stick on.
Yeah, right. But if you don't really want to do that kind of stuff, um, or want to have to do it less, then you or just want a more reliable first layer in general, you definitely want to think about, okay, like what is the actual um like where the print is touching the bed, what is the temperature there, and adjust your settings accordingly.
Yeah. So usually the more stuff in between your bed and the heater, the higher that offset needs to be.
Hmm.
It's kind of a judgment call. So on the Ender 3s, we just keep the bed at 60 throughout the whole print, and that's been working fine
Yeah.
with every PLA we've tried it on essentially. Some people will say print your first layer hotter and then drop your bed by a few degrees. That can also be good. I found it helps with certain materials, and specifically it can help with warping. So if your material has a low glass transition temperature, like some PLAs have a glass transition temperature of like 63 degrees, some of them have it like 60. If you can drop your bed temperature so that your first layer is hotter than the glass transition temperature, and the next layer, the bed temperature is lower than the glass transition temperature, I believe that helps prevent warping. And it depends on the material that you're printing. But if you have warping problems and you're keeping your bed consistently at like a hot temperature like 65, I'd recommend maybe trying 65 and then dropping it to 55
Hmm.
and see if that helps prevent warping, because I have found that helps.
Yeah, and that's also because with Quinley Vision we can detect warping. That's another
Yeah.
case where we would, if we see warping, we would have it also look and consider the bed temperature and see, is the bed temperature perhaps um, too low. Another thing that you have to consider with your bed temperature, which goes back to this idea of thermal resistance, is what is your ambient temperature? Because
Mhm.
if you're printing in a really cold room, you might actually need to crank the bed temperature up higher, um, just because it might not actually be maintaining the temperature you think it is at that top surface in the
Yeah.
cold room.
It's losing more heat from the top surface, and that might cause that top surface to be at a lower temperature.
Yeah.
So it's
Like I've noticed during I have a printer in my basement which can get really cold during the winter, and I will bump up the bed temperature by 5 degrees.
yeah, interesting.
Um, the other thing is with at least with vapor, I'm not sure about other print surfaces. You don't want to go too hot, um, because then the adhesion diminishes. But another consequence on all print surfaces of going too hot is you end up with something called a thermal gradient across your part. And plastics really don't like that because where they're hot, they'll expand, and where it's cold, they'll shrink. And the more extreme that thermal gradient is, the more like uneven shrinking and expansion you'll get. And then that can cause warping. So if you are noticing that you're getting warping and you're increasing your bed temperature and it's not helping, in fact, it might even be making it worse. It's because the warping may be caused by too high of a bed temperature, and then you should actually drop your bed temperature lower than you used to print at.
Yeah, I think one way that I found helps to think about it is when you drop your bed temperature, you're almost setting the shape of your part, because if it's dropping below the glass transition temperature, then it's turning from something that can be molded into something that's a rigid part. And with plastics, it's not a binary thing. Like there's a gray zone where when you're close to the glass transition temperature, it's kind of rigid, kind of moldable. But if you drop your bed lower, then it will become more rigid. I think getting that right helps prevent warping essentially.
Yeah.
But printing really hot on the first layer is fine, but then keeping it super hot, like keeping the bed super hot, I've found definitely can cause warping on parts.
Yeah. Yeah. So that's also something to consider, especially with taller parts, like maybe dropping the bed temperature a little bit over the course of the print.
Got some comments in chat.
They're
We've been
talking
talking about heat breaks.
heat breaks. Yeah. I mean, it's basically a lot of this advice, especially with temperature, comes down to like how do you prevent having any extreme temperature like changes in your print at any point during the print, whether it's when it's coming right out of the nozzle or whether it's being heated by the bed and cooled by the ambient temperature. You don't really want to have extreme temperature conditions on the first layer.
Mm-hmm.
That's why slowing it down helps. That's why having more heat come out in the form of like more hot filament, wider filament width, and taller layers for the first layer. Um, all of that is to kind of prevent the temperature from changing really quickly uh, when that first layer is being formed.
Cool. So I guess just an overview of bed temperature is having the correct bed temperature is important, but finding that correct bed temperature depends on your bed surface and how many layers of material there are between your bed surface and your heater. And also the material that you're printing, your glass transition temperature, where your material turns from a rigid shape to a moldable shape. It's okay if your bed temperature is hotter than that glass transition temperature on your first layer, but in best practice would be to keep it slightly below that for the rest of the print. And I guess as a bed temperature increases, that reduces the difference in temperature between the nozzle temperature and the bed temperature so that it doesn't drastically reduce the temperature of the molten plastic, so that maybe it sticks to the bed a bit better because it doesn't have such a shock.
Mm-hmm. Yeah, you don't want to shock the plastic at any point. It will jump right off the bed.
It'll scream.
Yeah, you go, and then come
You'll
off
hear
the
it.
bed.
It'll say, ah.
One thing that you can do, like I guess as a tip for testing the top surface of your bed, and this is not super accurate, but something I've done just as a quick test is I put my hot end touching the bed,
Interesting.
and then set the bed to a certain temperature, and then I look at like
Ah,
the hot end is off, so I look at like what the hot end reading is, because that gives you kind of like, okay, there's something touching the bed, and then the thermistor is like a centimeter above
yeah,
that. So like how much heat is actually going into the hot end. And now obviously like brass and aluminum conduct differently from uh PLA, but it's still like a kind of good, gives you a sense of, how much heat is getting dumped into the part from the bed.
yeah. I wonder if you could help that maybe with like some sort of water bath or I don't know. It's probably a bad idea, but
Yeah.
some sort of way
Like
to
a
like
calorimeter or something.
wet the nozzle just so that it makes contact with the bed.
At that point, you just get a thermometer.
Yeah, get
I
a
also have
thermometer.
a IR thermometer, but it's good to check. It's very important because once you know that offset, you can use it forever for every print that you do on the machine.
Okay, so we've covered the five.
Mm-hmm.
Now there's two secret ones that we don't really need to go into as much detail because they're not super complicated, but I just want to talk about first layer acceleration.
Okay.
It's similar to first layer speed as to why it matters. But the first layer acceleration is specifically and related to the corners of your part and why peeling occurs in your first layer. Like if you ever peel, or if you print something and then your nozzle changes direction and it just peels whatever it just printed off the bed. I think if you increase or you reduce your first layer acceleration, you can actually get rid of that. You can fix that effect. So yeah, we're looking in Cura here, and it says all of the accelerations in on the Ender 3 are set to 500, and that's the default. That's the firmware default, I think, for Ender 3. Other printers, the firmware default's anywhere from 500 or maybe 1,000 or maybe 2,000, all the way up to like 10,000, 20,000 for the high-end printers. But I think for the first layer, we can actually drop that acceleration down to like 200, maybe even 100 for really difficult materials. And that's specifically if you're getting peeling on sharp corners. And some of the first layers that we do are actually quite complicated. Yeah, Mateo's going to show us that part that we did. This is P5 for our Prusa Quinley kit. And this is the entire first layer. It's a very thin first layer. And there's a bunch of these sharp 180-degree turns. And we use, I think it's 100 millimeters per second squared acceleration just for the first layer. And then we increase it to 500 for the rest of the print. But this really helps the corners stay stuck down because what you'll find is the nozzle will kind of shake when it changes corner, when it changes direction so quick, and that actually can cause the print to peel up. So I really like this part. It's a good example.
This one also has a lot of small direction changes.
They haven't seen this one yet. There's maybe not a bunch of small direction changes, but on the edge there's some complicated features. But if you're having problems and you can reduce the first layer acceleration, I would say that it does sometimes have a noticeable effect of bulging the corners slightly. So you do have to be aware of that, but I don't find it makes much of a difference. But if you want your first layers to look absolutely perfect, maybe don't touch it. But I do find it helps increase the reliability of your first layers at a very small sacrifice of potentially bulging corners. So this is an interesting part. There's a lot of complicated stuff going on here.
Yeah, it's kind of hard to show. But I mean, this end has like a lot of loose.
Yeah, like just lines that kind of do have a 180-degree turn, or because this is a generated design. It wasn't, well, it was kind of modeled, but the way in which it was modeled, there wasn't, we didn't draw every single one of these triangles by hand. So some of them just happen to end on an edge or halfway.
It helps with these small curls inside too, like where the smallest triangle holes are.
Yeah.
Um, it just helps those stick down.
Yeah, I think it can actually help with the beginnings of lines because it has to accelerate from some speed to its final speed. So if you set that acceleration lower, then it will take longer for it to get to its top speed. Yeah, actually, you can actually see kind of on the tip of the Q there a bit of a bulge looking effect. I think it might start the line or end the line at that tip.
Yeah, it does. You can actually see it.
But yeah, it's really interesting. I like to look at 3D prints under really close up lens, or my phone has a pretty good microscope kind of camera. It's just really interesting to see how these things actually look once you've changed settings. So if you ever do this, maybe send us some photos of before and after you change acceleration. That's good to know. There's another one, another secret setting that I want to talk about. And this goes from being a good setting to use into Band-Aid fix territory.
Okay.
But I found this has been really helpful for really difficult materials. So stuff that will just not stick to the bed. I found it was helpful printing polycarbonate actually the first time I tried. I eventually figured out how not to use this, but it's called retraction extra prime amount. And what this does is whenever the nozzle retracts, it brings material out of the nozzle, and then when it unretracts, it puts the material right back where it used to be. But for this retraction extra prime amount, what it does is pumps out a little bit extra material. And the idea behind this setting is actually to get rid of, I guess, when material is lost due to oozing or stringing, you're replacing that material that's lost. And so it's already kind of a huge Band-Aid fix because you just shouldn't have stringing or oozing in your print. But I found it's really helpful on your first layers to create kind of a little blob at the beginning of every printed line. And that little blob sticks really well to the bed. And then you can move away from it. But I would only recommend using this if you actually have tried all the other stuff and it doesn't work, and you're still unable to get lines sticking to the bed properly. But it does help, and it does cause blobs on your print. So use it at your own risk, but it has helped me get some really tricky prints done with maybe some unique materials that you don't really have fine-tuned settings for.
Mm-hmm. Oh, Alice says, never thought about adjusting acceleration for the first layer. It makes obvious sense. I mean, I almost look at it the opposite way too, and not just adjusting acceleration for the first layer, but actually you want the rest of your print acceleration can usually be a lot higher than the first layer acceleration. So I know with some of our speed bench tees, like you put it up to 2,000 or 3,000, was it?
Ooh, up to 4,000, I think I was able to go.
Right. But you can't do that on a first layer. That's just, it would never stick. So you can think about it that way too, where you're just splitting the first layer acceleration from the rest of the print. Because why, like, if you can't get it, or I guess the question is, why would you hinder the speed of the rest of your print if the first layer needs a really low acceleration? So I'd recommend both ways. Lower the first layer acceleration and then try increasing the rest of the print acceleration. Because it does actually make a big difference to print time.
Yeah, that's actually something we've done on our parts recently, is just increase the acceleration for the rest of the print, not the first layer. And some of them almost like multiplied by maybe 1.5 times like the number of parts per hour we were getting from that. So
it's actually, it's insane. Like when I was trying to sync those printers together to move at the same time, I was sending one G code to a whole bunch of printers in our farm to see, just testing how fast our like job dispatch was and our networking for Quinley Pro. And there was one that had a slightly slower acceleration, and even though it was maybe a 45-second G code routine, you could already tell like it was falling behind very quickly.
Yeah.
Because that routine consisted of a lot of fast moves. So yeah, definitely consider increasing print acceleration and then decreasing the first layer acceleration.
Yeah, and actually, fun fact, I've gone all the way down to 25
Oh,
for acceleration.
it must sound so funny.
It is weird. It's like,
Yeah.
but it does. It actually ruins your first layer. Like it doesn't look good at all, but it makes it stick down super well. That was for
Was it for-
polycarbonate,
Oh, it was.
and I think maybe 25 was a little bit too low, but
That's yeah,
it took a long time.
yeah. Oh,
Hey, Bao,
check on Discord later. I made a video of it. It's pretty.
we should bump that on Discord or something.
I don't think we ever posted it.
Oh, did we not?
No.
Oh, cool. Okay, well,
Yeah.
we can post it soon.
Yeah, it looks pretty cool. Although one is slightly out of sync, which is annoying.
The one with weird acceleration.
It wouldn't save new settings for some reason.
Weird.
I don't,
Maybe it had a different star driver or something.
who knows? With Creality boards, you never know.
Yeah,
It could just straight up be a.
maybe there's like a hard-coded limit on that one and not the rest.
It could be an Aquila for all we know. Like you never
Who
know
knows?
what's inside actually.
Yeah.
Um, yeah, Val, I'll ping you when we send that video. It's really cool. Uh, yeah, it was a good test, and it did open my eyes up to like just how much of a difference acceleration makes. Um, but yeah, so those were our 5 + 2 tips.
Yeah.
Maybe we should give a recap of all of them in case, people join later. Just a
Brief summary. So maybe we'll just go over like the most important
point.
aspect of each one.
Sure. So initial layer height.
We want your first layer to have some wiggle room between the nozzle and the bed. And if your initial layer height is too thin, then your nozzle and your bed distance, there's not very much room for error there. So if you have a thicker first layer, first of all, more material is coming out, but also if your leveling isn't perfect or if your auto bed leveling didn't work too well, you can still get a first layer that prints okay. Especially with an automated system, that helps you get reliable results.
Yeah. And then for line width, a wider line means more surface contact with the bed, which means that line that you've printed has a higher chance of success. Again, it also means more hot material is coming out of the nozzle, and having more thermal mass on the bed is generally better for adhesion.
Yeah, print speed, slowing print speed down is also part of the equation for how much material is coming out of your nozzle. And when you slow that down, that means that the material coming out of your nozzle is actually reaching the temperature that you want it to get to so that it properly melts, becomes kind of liquid, and actually seeps into those little surface cracks on the bed so that it adheres properly.
Yeah. And if you're impatient and want to print your first layer fast so that you can walk away, well, a good way of compensating for that is by doing a wider line width at a lower speed, because then you're still getting a fast first layer. All the material is coming out at the same speed, or the volume is coming out at the same speed. But you also get the benefit of a slower moving nozzle. Or you can just use Quinley Vision to watch your first layers for you and tell you if anything goes wrong. Then number 4.
Initial layer nozzle temperature. So this is the nozzle temperature, specifically for the first layer. You can use whatever temperature you want for the rest, but for the first layer, we'd recommend having a really hot nozzle. And so for PLA, if you're using the settings that we said for layer height and line width, then you should have also a very hot first layer nozzle temperature. So we would recommend 230, 235 as a good starting point for your first layer nozzle temperature. And that's just to make your plastic super molten, very liquid, and so that it sticks really well to the bed.
Yeah, and that might sound like it's way out of the manufacturer's spec, but the manufacturer's spec is more about the rest of the print versus the first layer temperatures. So even if you print your first layer hot, you can drop those temperatures down for the following layers and still get a really good looking print.
Mm-hmm.
And then finally, we have bed temperature. Um, and bed temperature is important. Uh, most slicers get it right. You want 50 to 60 degrees for PLA, but it's important to understand your printer and the type of bed that you have on your printer. If you have a thicker bed, or if you have a bed made of spring steel, for example, it might take a different amount of time to heat up. And the temperature at the top of your bed is not the temperature your thermistor is reading, because the thermistor is under the bed. So you have to account for any sort of heat loss or heat transmission delay at the very top of your surface when you're setting your bed temperature. So that might
Mm-hmm.
mean bumping up the temperature if you're printing on spring steel or printing with a really thick glass plate. It can also mean bumping up your temperatures if the ambient temp is really cold. And it's important to know if you're getting warping at a really high temperature, that really hot bed could actually be the cause of your problem. So in some cases, you want to cool the bed back down.
Yeah, so just keeping it hot for the first layer and dropping it below the glass transition temperature for the rest.
Mm-hmm.
And then our two secret settings, the two ones that you might not know about. First layer acceleration. Usually people don't touch this. Usually you have one acceleration for your whole print. But if you have trouble with corners of your print sticking down, then if you reduce your first layer acceleration, so I'd recommend somewhere between 100 and 200 millimeters per second squared for your acceleration, that can allow those corners. It just gives the nozzle a bit more time to actually print those corners, so it doesn't try to take the corner super quick and peel it up. It actually slows down, lets that material melt and stick a little bit, and then it moves away slowly. So I found that helps, particularly with prints with sharp corners.
Mm-hmm. And then finally, the second secret tip, which is really just like a band-aid fix for tricky materials, is the retraction extra prime amount, where whenever the nozzle retracts, it puts a little bit more material than it should. Uh, that kind of thing also helps with increasing the surface contact after a retraction. Um, but it's like not a really good setting to rely on always, because it also causes excess material in the rest of your print. But if you're printing something like nylon or polycarbonate that has a hard time uh, sticking to print surfaces, it might be a good thing to try if everything else doesn't work.
Yeah. And actually, Cura doesn't have a way for that to just apply to the first layer
Mm-hmm.
unless you do some weird first layer modifier mesh. So if any
Okay.
Cura devs are listening, that would be really cool to have retraction extra prime amount for first layers only.
First layer retraction extra prime amount.
Yeah.
It's like,
They have first layer settings for most settings. They just don't have it for that.
yeah. And that's it. So once you master those things, you should end up getting very, very reliable first layers. And once you do get reliable prints on your first layer, that should free up a lot of time to start optimizing your prints. So once you've got reliable prints, that's when you should start experimenting with higher speeds or higher flow rates, and getting actually getting more out of your printers. Um, because if you don't want to optimize a part that doesn't work 30% of the time, you want to optimize a part that is reliable, because you can trace any changes you've made to any issues. And we're something we're working on in Quinley Vision and Quinley Pro is our tools for that, where when you introduce new models or print new models, you can actually check their failure rates or their cancel rates and have all that data for that experimentation. So if you're trying to optimize a part and you've increased its speed, Quinley Vision might notice that it's failing, the first layer is failing 20% of the time, where it used to be failing maybe 5% of the time. And then okay, the speed changes I just made uh, might be too fast. So let's bring it back. And being able to work with that kind of information is really, really handy, because most people right now, I would say most farm operators definitely just go off of feel. I doubt that any of us are documenting every single slicer change we make when we try to make a model go faster, because it's
Hmm.
literally hundreds of changes. So having something like Quinley Vision track that for you is just going to make your life a lot easier. Yeah, if you're trying to print faster or if you're trying to print more.
Yeah, and with automated printing, reliability is key, and the foundation for every print is the first layer. So if you can get that right 99% of the time, then that sets all the rest of your prints up for a greater chance of success. And it actually means you can kind of push the rest of your print a little bit farther because you have such a good first layer, and a
Yeah,
good foundation to work with.
for sure. The first layer is only a small part of your print. You have the whole rest of the print to optimize.
Yeah, so take your time with it. Don't try to rush your first layer. Don't try to squeeze optimizations into your first layer. Save it for the rest of the print.
Okay, cool. So that was our. Let us know if you have any questions, and we'll answer some of the questions from chat now. Um, so okay, let's see. Okay, Bao's saying what in reference to me syncing up the printers. This is actually one of the things I wanted to do it with, or do with the syncing the G code.
Hmm.
Like I've done it on my Rostock before, where you have like there's a MIDI to G code converter,
Oh yeah, yeah.
and you can make it play music. And I wanted to do that with our enders, but they were like they're not perfectly in sync yet.
That'd be really cool to get like an orchestra.
Yeah.
Turn your print farm into an orchestra. That would be like a sick thing to include as an Easter egg in Quinlan.
Just like cancel all prints.
Or when all your prints are done, when you like if you're on what is it, a shared queue, Quinley Pro, and when that queue finishes, it plays like a whole song.
This whole song. Yeah.
That'd be cool.
The test I did that I'll be posting in Discord later was wireless test. So it was that could have also been part of.
Oh yeah, Ethernet would have been helpful probably.
Yeah, it definitely would have helped. But I wanted to see how close we could get it over Wi-Fi.
Mhm.
Um, all of the printers in our farm are on Wi-Fi. Yeah, it was actually pretty easy. Well, it's pretty easy to do because we have everything built for it. Oh, Machine Creator is suggesting a Git repo for all slicer changes. I don't know
It's
if
gonna take a
anyone.
long time.
Yeah, I don't know of anyone who does that.
Like I can personally say I slice parts almost every day, and if I had to track those changes, it would just take so long.
It's not even like tracking the profile changes. It's like associating the profile changes to a specific part is what
Yeah,
takes a long time. Like
and also giving a reason.
yeah, going into the print farm and picking out the part and then going back. Um, Plus you don't know whether it's hard to tell from a single part whether it's an issue with the slicing or not.
Mm.
Like things that I'm looking at for Quinley Pro and also Quinley Vision is like things happening across your print farm. So if you slice a new part and it works well on all, like let's say you have 5 printers and you slice a new part and it works well on 4 of them, but the failure rate goes up on one of them, then that points to a printer problem. If the failure rate goes up on all 5 of them, then that points to a slicing problem.
Makes sense.
If your failure rate is good in one material, but bad when you switch to a new material, then that points to a materials problem.
Right.
So it's like all of
Or
that
maybe
kind
a
of
slicing problem.
for that material.
Yeah.
Yeah. But it like that kind of thing right now is so tedious to track. Like print farms that we
Yeah.
talk to, they're just like, well, they don't really track that. They usually have kind of one person or a couple people in charge of slicing that keep track of that in their brain. Um, but as soon as you like, even with if you have 10 different SKUs, it starts to get really difficult.
Yeah.
Like
Yeah, and I
even
think like most print farms that we've talked to, I think some have actually tried to do
Yeah.
tracking on this stuff, and we've tried to do tracking on our own print farm, but it just becomes so much work that it isn't worth it. And the only way for that tracking to be done efficiently is if it was done in an automated way with software. So that's what we're doing with Quinley Pro.
Yeah. Yeah, exactly. Quinley Pro and Quinley Vision, they have not just the input changes, but because you have the Quinley Vision engine actually looking at the output as well, that gets logged for you automatically, and then those associations are also made automatically, um, which is hugely important. Like especially if you're just one person, like trying to keep track of a whole bunch of different products, it's impossible. And if you're a team of people, it just gets even worse because uh, then that whole team has to communicate with each other. And because prints take a long time, one shift might start a set of prints, the other shift would um, see the finished prints, and then that shift would have to communicate back to the first one who sliced it, like if something went wrong, and that just gets really, really complicated. So the idea is to automate all of that. Um, or I mean, it doesn't even have to be different shifts of people. It can just be me starting a print late at night and then waking up the next morning and forget what changes I made.
Yeah. Yeah, like sometimes even on the print farm, if I'm about to leave the office and I can see a print isn't going so well, I'll literally just write on a sticky note, post it, like put it on the printer and say like change temperature and reduce speed so that when I get there in the morning tomorrow, I know what the problem is.
Which printer it went to too.
Yeah. I'll rate the part, P5, change temperature and speed or something.
Mm-hmm.
There should be a better way. That's what I'm saying.
Yeah. Yeah, also he has 200 SKUs for his store. And that's something we'll talk about in Quinley Pro is like how to track SKUs that might be the same part in different materials. That's kind of what the tagging stuff that we built is the start of. Oh, yeah, I guess one of the changes that I forgot about that's going to be pushed up is we've also changed, or we've built the engine that lets you process files based on what printer they go to and what tag they go to.
Mm-hmm.
So now it will be really easy to do things like adjust temperature based on what tags are applied to a job.
I'm really looking forward to that.
Yeah.
From our own print farm. There's also things I'm thinking now would be cool if specifically on the first layer, if you can find the first layer of print and process and say like reduce all the first layer speeds on these prints to 10 millimeters per second from whatever they used to be, and have that as a bulk process. So you could just select 100 files and say, I don't care what the print speeds were before, set it to 10.
Yeah, I think
That would be really nice.
the way it would work, or the way I'm thinking of having it work right now, is you would set like a default tag for that
Okay.
on all those files so that you could remove it or edit it in bulk as well.
Yeah.
Because like let's say you have 100 files and then you make that one change, you wouldn't want to have to like apply a new set of changes to all 100 files again.
Yeah.
You just edit the tag set of changes,
Mm-hmm.
and then it would apply to whatever prints the tag was on.
Yeah, because that's it's a problem I've noticed. Like with, like, say I have a print farm and I've got all these settings. Maybe on my first layer temperature is 185 for every print, right?
Mm-hmm.
And I want to update that to 230, like because I watched the stream and I realized that 230 is a lot better. I might not do that because of all the effort it would take to update 100 files.
Yeah.
Because there's no software tool to do that.
That's what we were talking to Out of Darts about too.
Mm-hmm.
That's what he was saying was like they've gotten to the point where they don't want to reslice anything because their G code is so good.
Yeah.
So they hand edit things like temperatures.
Yeah.
And so being able to provide a tool for that would be really useful. Because I know some people will also have different setups on different printers where like let's say you have a different hot end on one printer, then you would need a different temperature offset.
Yeah.
And yeah, all of this stuff that I'm talking about now is going to be like uh given to the people participating in pro beta to give feedback on and to give ideas on as well. So if you aren't already part of the pro beta and want to give your input on how these types of tools will work, I would definitely recommend joining it. Yeah, I was saying this is part of the Quinley Pro features coming in the future.
Yeah.
Yeah, definitely. If you want, if you want to give input on it, there's the first round of Quinley Pro Beta software should be going out, I think next week, or yeah, pretty much. Um, and then every time we do like a new, before we start working on the next big feature set, we'll get feedback from everyone to make sure that the way it's designed is working correctly for them.
Yeah, we're looking at Etsy integrations as well as because that's kind of a like a holy grail idea I had a while ago. And I think everyone's had this idea if you have an Etsy store, like, wouldn't it be great if your printer started printing as soon as an order came in?
Yeah.
Right? It doesn't need to be Etsy. It could be if you're running like a spare parts warehouse, or if you're printing, any on-demand print farm would want this, where their printer just starts printing as soon as they get an order.
I'm thinking even like school farm or university farms could, with the tag system at least, could like quickly block out any crazy settings that people submit.
Mm. Yeah, like only allow engineers to
Yeah,
print stuff.
or like whenever a print comes into the order queue, like if it has like 200 millimeter per second first layer,
Oh yeah.
it would just quickly adjust it for you without reslicing it. There's an app out there that automates the process of figuring out what to sell and breaks all Etsy listings into material, machine hour, cost versus profit. I mean that would be pretty simple to set up as well, because you would have in Quinley Pro you would have stats about what the machine time is for each part, and then you would be able to calculate that easily. The issue with doing it with manual printers is that your machine time and human time varies so much depending on like what time of day you printed the part or who was available to reset the printer. Because, you know, if you have a print that takes 1 hour, and you do it during the day and you reset it once it's finished, then it took an hour of machine time. But if you have a print that's 1 hour and you started it right before you went to bed and you don't get to it until, you know, the next morning, 8 hours later, then that part technically took 9 hours of machine time. And so doing those types of profit calculations becomes really difficult, which is why automation is good, is it because it runs consistently and doesn't depend on people. So your part cost ends up being a lot more consistent. Are you planning to replace tools like Katana? To some extent, some of the things in Katana I think would be really good to have directly in Quinley Pro. Like a Katana, which we use, is not super great for like partial fulfillment of orders, tracking that kind of thing. Like when Carlo gives me a PO for ordering parts,
Mm-hmm.
there's no way of marking whether something is like in transit.
Oh.
Yeah, you can only mark that it's been received. And that's really hard for printed parts because there's this state between when something is done printing and when the print has been requested where it's in the queue that needs to be tracked. Um, and things like Katana don't track that kind of thing. So yeah, it would be like a kind of a manufacturing software, or focus more on manufacturing features. Like, but even if you're just making one part, I think it'll be really useful just because you'll have more data about that part, and you'll be able to see like where you can increase the efficiency of your farm. Which, if you're selling stuff, you know that there means increasing your margin directly.
What is this new accessory toy from Creality?
The spool has sensors to weigh the filament spool, but only goes up to 2 kilograms.
That's
Interesting.
pretty cool. So it's directly, instead of estimating the filament based on slicer data, it's a real-time feedback. That's actually nice because it's kind of hard to do filament tracking. I mean, you can do it, but you have to assume that you're loading it with full spools.
Yeah, I've thought about filament tracking a lot. There's problems with doing like weight sensors too, because if you have to move the spool, and you need to know the weight of the spool as well.
Yeah, you would probably have to stick with one spool type.
Yeah.
If you do, I think you can get away with it, but
Some manufacturers are nice to tell you how much a spool weighs,
yeah.
but
But if
you
you're mixing brands, it's gonna be
yeah,
hard.
and you also might not have exactly 1 kilo of material on there. So I'm not sure what the like I think you'd get within 10% of the spool being empty, but then like software estimation is within that margin too. So I don't know.
Here's a fun idea: using a filament weight sensor as a clog detector. When the weight isn't changing, but the printer is printing,
Yeah,
then you have a clog. It's
I
gonna be
thought
pretty
about
noisy,
that
but
too. Yeah.
it's probably usable until you like start ironing for like a whole layer, and then it realizes that,
Yeah,
that there's actually still material coming out.
there's
It's really
still
slow.
yeah, I
Probably wouldn't work too well.
thought about that. I thought about like using encoders, but I think filament the input is not consistent enough. Like
There are encoder-based clog detectors now.
yeah, but I think you wouldn't be able to measure like how much of a spool is remaining
Oh no,
ever.
no,
Yeah.
probably not.
Yeah, you'd have to use yeah, I think right now like a software solution is pretty much just as good as a scale unless you know exactly what your filament spool weight is and how much filament is on the spool itself.
Yeah.
Which some manufacturers give you for sure, but many do not.
Mm. Yeah, the only way that like might work is if you could somehow have a smart spool that would know how much filament it has on it,
That's like what
and then
Ultimaker does.
yeah, and then you'd have to have all these like RFID stuff, and then
Yeah, they have
that gets
the
into a whole other thing.
NFC spools, and Da Vinci also had something like that,
Oh yeah,
but it was like DRM for their filament,
right.
but it would track how much is left. Yeah, but still, it's like I don't know. It's kind of complicated.
See, I mean, I still want it to be. I still want to see a future where we just have pellets
Yeah,
at some point.
that's a
Pellets are
true
so cool.
that's a true solution.
Like it's just you just dump a whole 1 ton bag of pellets, and then they get distributed to like 100 hoppers, and then you have 100 printers printing from those hoppers. Like
Yeah,
that would be the way. But that requires a whole bunch of yeah. You have to have pellet extruders on all your printers.
yeah.
That's a whole thing.
That's there's no like I don't know if there are any lightweight pellet extruders.
No, I could almost see it for some applications, like for anything that doesn't require good quality or uh, retractions, I guess.
Mm-hmm.
Um, Having a huge print farm with a distributed pellet network would be nuts. That would be so cool.
That'd be like built into the facility though.
Yeah,
Yeah.
it would have to be almost like a factory. Like this is like 10 years down the line when Quinley's working in like actual industrial facilities of like plants,
Yeah.
like hundreds of printers being fed by hoppers, and they're all automated. No one's changing filament because it's all pellets. And
You just dump the pellets in once a month.
yeah, and it's going through like a kilogram of material per second or something.
Per second.
Yeah, not per printer maybe, but like across 100 printers.
Yeah, yeah. That'd be cool.
Yeah.
I think you could well we talked about tracking filament with Quinley Vision. Like we can already detect
We can detect run out
run
or
out,
clogs.
yeah, and clogs. But we also talked about like looking at the spool. If you have
when
the
when it
spool,
goes from like having stuff on it to not.
yeah,
Yeah, I guess you could.
Like it's pretty easy to get the spool in view for a lot of printers. I don't know. That would be kind of cool.
You might, oh, if you had like a, you have like a certain area of your screen that you have to put your spool in, right? It's got to be on
Yeah.
your right side. But maybe you could like draw a box around your spool and then keep it in that spot for the rest of
It
your
wouldn't
print.
matter where it is. It just like it would have to be in frame.
Mm.
Yeah. And then you'd be able to tell like when it was on the last
Right, yeah, just
spooling.
like a single line. It'd be like stringing. You just get one line and then, oh,
Yeah.
time to replace your spool.
Yeah. Luckily, it would like look pretty consistent too. Hmm. Yeah. I thought about it. You can also use like QR codes to identify the spools. Set up monitoring zones. Actually, yeah. I guess you could set up like just draw a box around the spool.
Yeah.
Hmm.
Probably
Maybe
done.
stretch goal, stretch goal.
Stretch goal.
If we get to 1 million, we'll do that. Filament level detection.
Spilled water on myself.
Does that mean it's time to end this stream?
Yeah, I'm overhydrated, guys.
I
I
think
tried to add more water to my body and rejected it.
it came out.
Couldn't
Yeah.
do it.
Okay. Well, yeah, make sure so yeah, keep an eye out on Discord for the Quinley Vision bot that you'll be able to interact with. Um and what else?
If you have an Ender 3 Max or Genius, we have betas out right now for that. Multi-hub is rolling along, and Quinley Vision time lapses and automatic updates are coming soon.
Yes.
So stop flashing your SD cards.
Fine.
Well, you'll have to do it one more time, but then you won't ever have to do it again.
One last SD card flash.
Yeah.
Yeah, so we'll see you next week at the same time. Uh, try to keep your eyes out for some articles about Quinley Vision. Apparently, we're featured in Yahoo Finance. Share those articles around, get people excited for it, and yeah, get people excited also for the demo we'll be setting up in our Discord server.
Yeah, actually, that's a good point. We should get, if you have anyone that's not already in our Discord or any friends that you think would be interested in sending their own failed pics to an AI and seeing what the AI thinks of it, tell them to join our Discord and sign up for our Quinley Vision trial.
Yes. Kevin said you're experiencing hydrolysis.
Hydrolysis. Oh no.
Actually,
Oh
it
no.
perfectly covers the dot on your shirt. Oh no, it's out of
Kind of
frame.
on my button.
Okay. All right. Well, we'll see everyone next week. Thanks for joining us. Hopefully, this was useful. This is definitely took a long time to learn this stuff. Yeah.
Cool. Hope you guys have good first layers.
Yeah. Good first layers for everyone,
Yeah.
and no hydrolysis.
Hydrolysis.
All right. See you next week.